Hi, my name is Michael Lavara, and welcome again to part 3 of paint material effects testing, where I look at 100 low lead versus G100 UL and the effects it has on aircraft materials and paint. In this episode, I have a lot more to dig into, specifically with more aircraft that have had issues since the last update. And while there's some timely updates in this video, I'd still recommend watching my 2 previous videos on this subject. So, what's in this update? There's been a lot of discussion since my last video, along with AOPA and EAA weighing in on the topic. I clarified some of the paints on previously tested panels. There's additional aircraft reporting issues, including a Cirrus. I did some further paint tests, repeated my easy turn fuel lube testing, tested some hoses, and I'm going to pose a couple other questions. AvWeb's done some pretty fair coverage, pitting me against GAMI with our fuel and paint tests. There's also been the FAA getting involved in Watsonville looking at several aircraft. And there's been more industry weighing in. AOPA presidents asking for feedback from users of 100 octane unleaded fuel. And there's a user experience form you can fill out. And lastly, EAA weighs in. And I think this is an important part as I'm going to look at the RV6 that's had issues. In the first 2 videos, there was a lot of discussion about the paint on my Citabria inspection plates. I was able to reach out to the painter who painted my aircraft. And on the non-fabric surfaces, he typically used DuPont Centauri acrylic enamel. And again, I want to reiterate, this paint had no issues with 100 low lead throughout my testing. Just so it's clear, the Citabria inspection plates were DuPont Centauri in 2003. Cessna 182 inspection plates were an epoxy primer in Sherwin-Williams Jet Glow in 2005. The Pitts part, which is orange, was an epoxy primer in Randolph Ranthane painted in 2024. And then there's a whole sampling of random panels with unknown paint origin that previously had no issues with 100 low lead. Reported issues in the field seem to be increasing. There's a Cessna 182 with a bunch of goo coming out of the wings that looks like the AOPA Baron, a Cirrus SR-22 at Reed Hillview that has paint damage, and Cirrus came out and inspected it, reporting that they believe it's compromised the carbon fiber composites. And then there's a Mooney at San Carlos that again has some leaks and paint deterioration. I'm also aware of several aircraft operators who've ceased using the fuel due to staining, including one Mooney owner who spent $500 to have a shop remove the stains on his wings. I also have anecdotal reports of individuals stating they're seeing an increase in clogged injectors after using G100UL. Time will tell if this is related to the use of fuel or just a coincidence. The affected owners of the RV6 in Watsonville that I reported on last time reached out to me, and I was able to go look at the aircraft. As you'll see, the paint damage was one of the worst I've seen to date. So the 2 photos that one of the RV6 owners put on Van's forum didn't really do the damage justice. Quite frankly, I was shocked when I saw the aircraft. The left tank had emptied its remnants of G100UL, which was a quarter tank, into the cockpit, down the bottom of the left wing, down the entire fuselage, all the way to the tail. It ate the paint and primer inside the cockpit. Several sections of paint are missing on the bottom of the fuselage and are heavily compromised, all the way back to the tail. And as you can see here, this damage is quite severe, and likely came from fuel both inside and outside the aircraft, getting underneath the painted surfaces. Unless there was some mystery solvent in the hangar that day, I've never seen paint damage like this from fuel. The current owners of the RV reported to me that it was painted with PPG Concept acrylic urethane paint, which is not an abnormal paint in the home-built community. Along with the owners, I helped them borescope the left fuel tank. And what you see here is a view of the left filler cap from the inside of the tank. And my finger easily rubbed off and removed some of the Pro Seal. And as you can see in this photo, there's a little clump of the Pro Seal down at the bottom of the tank that I rubbed off with my finger. I was able to use the tip of my inspection camera to put some marks in the Pro Seal, which didn't recover as quickly as I thought it would have. About 2 weeks after visiting the RV6, one of the owners gave me the following update, and he said that after draining the tank and filling the other tank with 100 low lead, he's noticed the Pro Seal is hardened back up to what seems right. You can no longer easily run it off with just finger pressure. Poking it with a screwdriver only leaves a mark where it's super thinly applied and not doing anything anyway. At the corners where it's thick, it doesn't show marks and it's hard to chisel off. The owners reported to me that George Braley, the head of engineering for GAMI, was out on the 2nd of February to look at their aircraft. While there may be a difference of opinion on the quality of a particular fuel tank, there are over 11,400 Van's RV aircraft that have been completed and flown. It certainly begs the question of how many of these aircraft that have no issues with 100 low lead might have issues with G100UL or any other new fuel. I'd like to compare this, though, with what Vans has put out in their YouTube channel on how to build an RV tank. And noted here in the video is the receptacle for the fuel filler cap in the wing. And the construction method here is shown how they apply the Pro Seal. And that doesn't look different from what I've seen here on the RV6 that's affected in Watsonville. I realize that RVs are not certificated aircraft, but if a common builder follows the guidance given by Vans and has had no issues with 100 low lead, it begs the question of what's going to happen with transitioning to new fuels. What percentage of aircraft that follow this guidance are going to have potential issues in the future? The November 2024 issue of Sport Aviation magazine from the EAA had an article titled The Future of Fuel Systems, and I'd like to point out what's highlighted in orange here, specifically that experimental amateur-built owner-operators need to be certain that the fuel they're using is safe for their particular aircraft and its unique materials and systems. Unfortunately, I think this particular RV6 in Watsonville is going to be a sacrificial lamb in our transition to unleaded avgas, and highlights the concerns with experimental amateur-built aircraft and G100UL. In late January 2025, a 20-ton model, original factory-painted Cirrus SR-22 at Reed-Hillview reported issues. To date, both Cirrus, the FAA, and GAMI have inspected the aircraft, and analysis is ongoing. The aircraft started using G100UL in November 2024 and ran an approximate 50-50 mix of 100 low lead and G100UL over the following months. Flight tracking shows approximately 11 hours accrued over 8 flights throughout those months. The aircraft last flew on January 9th, and no issues were noted with the aircraft. The owner came out to the hangar on January 20th and noticed drips in the wheel pant, followed by discovering the damage on the wing. And while analysis is ongoing by Cirrus, the FAA, and GAMI, the damage here is very similar to what I've been reporting over the last several videos, where fuel leaks and then the paint and primer is damaged. It is my understanding that Cirrus currently has concern about the airworthiness of the aircraft and potential damage to the composite structure due to the leak. This photo further details the left wing at the wing to fuselage and landing gear intersection where the paint's compromised. This particular aircraft is another extremely important data point in the use of G100UL, specifically because Cirrus put out a service advisory in 2024 that stated that they do not approve the use of GAMI G100UL in any Cirrus SR series airplanes. And this discussion is only further amplified because GAMI's responded to Cirrus's service advisory and says there's no effect on safety of flight, airworthiness, or warranties. There's no doubt that the damage on this Cirrus will spark further discussion and analysis going forward. Let me pivot to a couple other aircraft that I have updates or new information on. The following 3 photos are of an affected Mooney at Reed-Hillview, and this is one of the earlier aircraft that I did not have photos of until recently. While the paint on the aircraft is quite dated, it's still showing stress from G100UL usage. And these 2 photos are from a Mooney in San Carlos, California, that as I understand only ran 1 tank of G100UL, and now has some serious staining on the top of the wing, while minor damage on the bottom of the wing. And at the end of January, this Cessna 182N model at Reed-Hillview, which has bladders that are about 3 years old, reported a gooey sludge coming out of areas near each wing's fuel drain, near the intersection of the wing to the fuselage. At this point in time, the exact cause is unknown, but the owners of the aircraft reported that this only started happening after they filled up with several tanks of G100UL. Those who have followed my videos have noted that there's seemingly an internet battle going on painted surfaces between me and George Braley. And he recently annotated this video where he shows a drip test on some Bonanza louver panels, which I'll point out are the only type of paint that he's shown publicly that he's tested. More on this topic later, and if you're wondering, yes, I did test Bonanza panels. I've managed to stay pretty quiet on the internet forums regarding this topic other than releasing my videos, but a recent post by George Braley, where he claimed several photos from the FAA's PAFI Lessons Learned document where damage actually caused by 100 low lead, caused me to interject. His claim basically said the FAA was misleading us by the Lessons Learned document since he thought the damage was caused by 100 low lead. So what do? You go right to the source. I wrote the FAA's Fuels Initiative, and they responded within a day saying the 2 images from Lessons Learned 5 of the PAFI Fuel Development Lessons Learned document are indeed from a PAFI candidate fuel and not 100 low lead. It's extremely frustrating when a topic of G100UL quickly gets attempted to be turned to 100 low lead. And in George's attempt to deflect the discussion from G100UL, he said that the PAFI program hasn't been transparent. Well, I do see that they've published their materials compatibility test plan and their materials test matrix. I'll ask you, George, where's yours publicly stated on what you've tested? Posting that would be an excellent example of transparency, instead of the "trust us, we know what we're doing, our fuel does not affect airplanes." I'm scrolling through the 190 or so pages of the materials test plan that PAFI's put out when a candidate fuel is submitted to them. It's actually quite impressive, and there's a lot of interesting things in here that I've learned looking at their document on testing fuels. And then this section is a very comprehensive spreadsheet that shows numerous material compatibility, whether it's composite structure, painted surfaces, metals, hoses, fuel cells, that they work on testing in the PAFI program. One of the interesting things I found is how they do a fuel drip test with a peristaltic pump. You'll see later how I took learnings from this document and applied it to my testing methods. Test plan and test matrix aside, let's talk about the STC versus the PAFI process. What's the difference? I do think there's a bit of confusion on this topic. The Eagle website has a great Q&A section on this topic. Specifically, the traditional STC process, the applicant, in this case GAMI, is responsible for demonstrating that the aircraft and engines meet all applicable regulations and minimum standards on the normal certification process when using the new unleaded fuel. The FAA reviews this compliance data provided by the applicant, and upon approval, issues an STC. And so GAMI has to show compliance to the test plan that's agreed upon with them and the FAA. And I'll note that this test plan and data is privately held between the applicant and the FAA. Contrary to that, under the PAFI initiative, the FAA does the testing and analysis developed in collaboration with industry to determine if an unleaded avgas qualifies as a replacement for approved leaded avgas. The data obtained through testing supports the development of the ASTM production specification for the candidate fuel. This would then result in a fleet authorization report, which also would include experimental aircraft. While I've attempted to test a variety of paint systems and aircraft panels, GAMI to date has only shown Bonanza louver panels in their paint testing. So I acquired 2 Bonanza louver panels, both of unknown paint and vintage. I suspect that they're likely factory painted with Imron or Sherwin-Williams. I tested these side by side with 100 low lead and G100UL. And as in previous tests, I subjected the worse off panel to 100 low lead, giving it a disadvantage to start. For this test, I decided to segment the panels, one half with no prep, and the other half with rubbing compound and paint gloss, polished out to a nice finish. Remember, the goal of my testing has been to mimic the typical GA fleets, and while some people might opt to spend money for ceramic coating, a wax is typical for most GA aircraft. For this setup, I attempted to mimic what the PAFI program does by dripping fuel on a slanted panel. The panels were rigged above a tray, and a couple times a day I'd pour about a ½ ounce to ounce of fuel down the panel from about mid-span, letting it drip down. As you can see here in these photos, there's a sheen where the fuel is applied. After a few days, I started to see slight paint degradation around the screw holes near the bottom of the panel, and at the contact area of the panel to the metal drip pan. Again, no issues were noted on the 100 low lead panel. A few days later, some equipment arrived that I had ordered, specifically a peristaltic pump system that would allow me to drip fuel on a regular basis down the panels. This would much better mimic a slow leak rather than me manually pouring fuel down the panels. I monitored all the panels closely. The 100 low lead panel didn't have any damage, and these 2 photos show the damage around the screw holes and edges of the G100UL panel after about a week duration. I then elected to lay the panels flat, with the edges overlapping another sheet of aluminum to mimic a lap joint and seam. This setup better mimicked a flat surface like a wing or bottom of a fuselage. As you'll see in the next few photos, laying the panels flat did seem to accelerate some of the damage where the fuel would remain standing on the edges of the panels for longer. Again, 100 low lead had no issues. Some paint deterioration was starting to occur on one of the louvers on the panel, along with the edges showing some stress. I will say whatever this paint is fairly resistant, but it was still affected by G100UL around edges and cracks and seams. By releasing the fuel slowly out of the peristaltic pump, I believe that I was able to mimic a slow leak, and allow the fuel to sit on top of the surface and not wash away the fuel on a regular basis. My observation here is that the paint was softened, especially where it was stained, and I was able to smudge it. So let's summarize the Bonanza louver panels. Whatever paint is on the panels is very resilient, but it was still affected over time, and maybe not to the extent of other paint brands that I've tested. Wax did seem to delay the onset of deterioration on the surfaces. Surfaces where fuel residue sat softened the painted surface over time. Edges, cracks, and screw holes seem to provide an entry point to where the paint then is compromised. There was no apparent damage to the panel that was subjected to 100 low lead. And another observation that's interesting is 100 low lead has a different surface tension and viscosity. It spreads out over a wider area, whereas G100 UL is more of a narrow drip or stream that's concentrated. I acquired some spare Mooney oil access door panels that I decided to test against G100 UL. I cleaned off the panels, set them in a tray, and applied a little bit of G100 UL to them on January 30th. As you can see here, the panels were in pretty good condition. Multiple colors with metallic paint. Here you can see where G100 UL was poured on top of the panels and then let sit. And this was the result on February 1st, 2025, only a day later. I transferred the panels to some plastic containers and I didn't apply any more G100 UL to them. The panels were set aside for 2 days, and on January 3rd I attempted to scratch some of the unaffected paint in the center, and as you can see it was pretty resilient. I then took a towel with my gloves on and rubbed the paint off the exterior of the panel. As you can see here, the center is still attached securely, whereas the outer side was stripped pretty cleanly. Again, I don't know the paint origin on this panel, but it seemed like a pretty high quality metallic painted surface. Aside from aesthetics, paint's really there to provide an anti-corrosion protective surface, which consists of a primer and top coat. The paint quality and preparation may affect resilience to G100 UL, but what I've seen is if G100 UL gets on the backside of paint, whether through cracks, edges, or rivets, it's highly likely that the primer and paint will be affected. I think it's really important to point out that the FAA does not mandate a specific type or brand of paint or primer to be utilized on aircraft. This chapter excerpt is from the Aviation Maintenance Technician Handbook on aircraft painting and finishing. And you'll note here that it does point out certain chemicals which are harsh on painted surfaces, some of which are within G100 UL. It also talks about various methods of applying finish and coatings that can be used on aircraft. I haven't done an extensive test on hoses, but I took a quick look at some MIL 6000 hoses when placed in 100 low lead and G100 UL. The reason I did this is because legacy aircraft have rubber-type hoses, Bonanza or MIL 6000, in the fuel system in several places like wing to fuselage interconnects. Here's some 5/8 and 3/4 MIL 6000 series hoses before I place them in their respective containers of 100 low lead and G100 UL. After 1 day of being submerged in the respective fuels, I pulled the little hose segments out. And you'll note here the G100 UL MIL 6000 hoses had swelled significantly. I monitored the hoses for several days after removing them from the fuel, and the G100 UL swelled hoses did contract in size. What the long-term effects of the fuel on these hoses are, I don't know just yet, but it still raises many more questions about materials compatibility. Legacy aircraft, like a Cessna Skyline, have Bonanza and rubber in the fuel system. This is likely hard to get to, and in many aircraft in the fleet. Take, for example, the P-51 Mustang. In the engine compartment, there are several rubber hoses called out for, which are AN 884, or better put, MIL-H-6000. A limited category P-51 would require a field approval, which means you have adequate data to know if it affects your hoses, or even an experimental would require the owner-operator to determine compatibility. For an additional data point, I reran my Easy Turn AK fuel loop test with 4 samples of fuel, 2 G100 UL samples obtained on 2 different dates, a 100 low lead sample, and then the 50-50 mix of G100 UL and 100 low lead that I removed from the Cessna 421. The only real difference in this test was that I tested the Cessna 421's fuel, which was a mix of 100 low lead and G100 UL. The results were the same. 100 low lead was unaffected, whereas anything that had G100 UL constituents affected the Easy Turn, aka fuel lubricant. And there's still a few open questions from my second video. GAMI has still not addressed my findings on easy turn lubricant, nor have they addressed my question of if fabric systems have been tested with G100UL. What about other aircraft components? This brings up the question of airboxes or induction system components. How many of us commonly see blue residue from 100 low lead in areas of the engine compartment? Aircraft induction systems and their components seem to be exposed to fuels on a regular basis. Many aircraft have rubber or silicone flappers in the airbox that are exposed to fuel. And what about induction air filter elements that might be exposed to fuel? I'd be interested in looking at areas like this more because if any of those items are weakened by fuel, the constituents could make their way into the induction system and engine, resulting in a possible safety issue. Another question that came to mind is, has G100UL been tested with cabin heaters like Southwind or Janitrol? So to summarize, again, these are my personal observations and beliefs. In the name of transparency, airworthiness, and safety, I urge GAMI to release data on materials compatibility testing that they have performed. It's becoming ever more clear to me that ASTM and consensus-based standards play a vital role in fuel testing. The number of aircraft reporting issues is not insignificant, and I reiterate my call for further materials compatibility testing before such a fuel is deemed a drop-in fleet-wide solution. There's decades of 100 low lead and 3+ years of UL94 usage at Reed Hillview and Bay Area airports. And I am aware of no paint issues like have been noted in only several months' usage of G100UL. Experimental amateur-built aircraft need guidance and a clear pathway for individuals to determine aircraft material compatibility for use of a fuel like G100UL. And lastly, the reported Cirrus issue is extremely significant in this discussion of materials compatibility and cannot be ignored or dismissed. Let me leave you with this Aviation Week viewpoint, which is titled, "For Unleaded Avgas, It's About Liability." There's some striking parallels in this article to our current situation with avgas. I've included the following resources as links in the video description below. Again, thanks for watching and have a great day.